All right, good morning. Hello. Today is March 30th. It's A3 Precalculus CP time. Just a couple reminders. Make sure that you do have your webcams disabled, your microphones muted. If you have any questions throughout this, you can feel free to interrupt and ask. You can also type any questions in the chat. Make sure you also fill out that attendance form on Google Classroom. Please do not forget to do that. Okay? It's just the same form as usual, nothing out of the ordinary. Just go ahead and click that form and sign in for attendance. Today, what I would like to do with you is I'd like to teach you something today called the law of sines, which is another formula relationship that we can use involving triangles. I did post an answer key of that area of triangles worksheet for you on Google Classroom. I posted that this morning. I worked it out this morning at like 7:15 in the morning. So if you have any questions on that, please refer to the answer key. And if you have any additional questions, please feel free to come on back during the faculty office time at the end of the day today from, 1:30 to 2 p.m.? Yeah, so feel free to come back at that time and ask. I want to make sure I take the entirety of the 30 minutes to explain to you, as best I can anyway, the law of sines. So you are more than welcome to come back and ask any questions later. You are more than welcome to refer to the answer key. You're more than welcome to email me if you so desire with additional questions. But I do want to make sure that I maximize the amount of time that we have together to talk about the law of sines. All right. One other thing I want to tell you before we get started is today we're going to talk about the law of sines. Next class, we're going to talk about the law of cosines. There's also a law of cosines. That's going to be on Wednesday. After that, on Friday, pretty much going to have a review wrap-up day where I talk about the area of the triangles, 1/2 AB sine C, the law of sines, which I'll show you today. We'll do a law of cosines problem just to make sure we're all on the same page. I am as well going to give you a progress assessment on Friday that is going to be due on Tuesday because that's the next time we're going to see each other. What is that progress assessment going to look like? Well, it's pretty much going to be a document with a couple problems on it that I ask you to take a picture of your work and send your completed work on Google Classroom, like to submit it on Google Classroom like you would other assignments for other classes. Okay? It is important that you complete this to the best of your ability. There will be a summative assessment on this stuff eventually. Again, I don't know what summatives look like at this time, but there will be one eventually. So please make sure that you take this seriously and do the best you can. All right. Again, if you do have any questions, feel free to come to the office hours in that 30-minute span, or feel free to email me separately after consulting the answer key. All right. So hopefully that clears up everything. I did know it's Kat's birthday. Kat, you're getting a little shout out. Happy birthday, Kat. One other thing that I want to make sure I mention to you is I did send out an email to anybody with missing work, and I provided all the work via email, so I'm asking that anybody gets that done, please, by the end of the day on Friday, so that I can make sure everybody's grades are all updated and up to speed on Saturday. All right? Fantastic. So today, let's go ahead and learn some law of sines. The law of sines is something that links together all of the sides and angles of a triangle. All right? There is a long explanation as to how to prove the law of sines, as to where it comes from and why it exists. Since we only have 30 minutes together, I don't want to spend time on that. I will give you a link to a great video, I think, that does a really great job explaining where the law of sines comes from, why it exists, and all that great stuff. If you're interested on your own time, you can certainly watch that. But what the law of sines states is that for any triangle, if I have a triangle, right, just any old random triangle, I'll call it triangle A, B, C. Again, that would imply that side A is across from angle A, side B is across from angle B, and side C is across from angle C. Then we can say it is true that in any triangle, not just a right triangle, any triangle, that the sine of A divided by A, so the sine of angle A divided by side A, is equal to the sine of side B, or angle B divided by side B. And that's also equal to the sine of angle C divided by sine C, or divided by little c. Okay? So it's the sine of angle A divided by A is equal to the sine of angle B divided by B, which is also equal to the sine of angle C divided by C. In other words, that ratio of any side to the sine of its angle is equal to each other. These are all the same. This divided by this is the same as this divided by this, which is the same as this divided by this. Okay? So we can actually use that to solve for any missing angle or side of any triangle in the whole wide world. All right? So consider an example like this. If I gave you a problem that said, solve the triangle. And when you hear instructions that say solve the triangle, what that really means is you're trying to find all missing sides and angles. So you want to be able to find all sides and angles. Just a little heads up. That's what that actually means when you say solve the triangle. It means find all sides and all angles. All right? Suppose we have a triangle that looks like this. Ready? Here's my A, B, C. I have 60 degrees. I have 40 degrees. And we're going to say that this is 8. Okay? So I could use my law of sines, just given this little bit of information, to solve for the remaining sides and angles of this triangle. You could say, the way I want to do this is I really want to start by looking for things that are across from each other, right? We're given this angle C, but I don't know what this side C is. But I can use this new equation that I just gave you called the law of sines to figure that out. So I can say, using my law of sines, that the sine of 60 degrees over 8, because that's side A, is equal to the sine of 40 degrees over C. And I don't know what that C is, but I can certainly solve for it. Does that make sense? Because you're just saying the sine of any angle divided by the side opposite to it is equal to the sine of any angle divided by the side opposite to it. For all three sides in a triangle, that relationship is always true, which is pretty cool. All right. In order to solve this, I would essentially cross multiply both sides by C, and multiply both sides by 8. You would get that, let's see, C times the sine of 60 degrees is equal to 8 times the sine of 40 degrees. You could now divide both sides by the sine of 60 degrees to get that C is equal to 8 sine 40 over sine 60. You could go ahead and plug that into a calculator. Last time I didn't have a fancy schmancy graphing calculator, but bam, now we got one. So I can say we got 8 sine of 40 divided by sine of 60. And we get that C is approximately equal to, we'll just round to 5.9. So we can say that C is 5.9. So that means that this side is 5.9. Now we can work on angle B and side B. The nice thing here is the fact that I'm given two angles means I could very easily find the angle of my third angle of the triangle. We know that all three angles of the triangle have to add up to 180 degrees. So I could say we have our, oh, look at Adam, already in the chat. Bam, B is 80 degrees. We have our 60 and 40 makes 100. This has to be 80 because that totals are 180. And now I can just do the same thing where I set up that sine relationship. You could choose either angle A and side A or angle C and side C to work with. I would personally recommend choosing angle A and side A because that's what was given to us. Notice we didn't have to approximate like we did with C for that. You could certainly use that and you would get the same correct answer. But again, since we rounded and since A definitely has some nicer numbers, I'd want to work with that. So we can say that, where are we here? I can say that the sine of 80 degrees, that's angle B, divided by side B, which I don't know, is equal to, we'll use A, the sine of 60 degrees divided by side A, which is 8, sorry. Now, again, cross multiply. I can say that 8 sine of 80 is equal to B sine of 60. Let's divide by the sine of 60 on both sides. So I get 8 sine of 80 over the sine of 60 is equal to B. Again, handy dandy calculator. I would just say 8 sine of 80. Make sure you're in degree mode as you're doing this. Divided by the sine of 60 is equal to, we get that side B is approximately, we'll call it 9.1. And now we've solved for all of the sides and all of the angles of that triangle. Did that make sense to everybody? Hopefully that was logical. Yes? Okay, let's do another example. Another example where we're given two angles. So let's solve the triangle. Okay? Let's say we got an ABC situation going on here. A, B, C. What if I told you that angle A was 30 degrees, angle B was 45 degrees, and this side was 2? Okay? Could you use the law of sines to solve the triangle? Well, certainly you can. The first thing I would look for is things that are across from each other. This really helps me get started, and now I could look for what side B is, right? Because we don't know what that is. So we can say that the sine of 30 degrees divided by 2, that's your angle A and side A, how they're connected, is equal to sine of angle B divided by side B. That's sine of 45 divided by B. And we can now go ahead and solve for B. Multiply both sides by, like cross multiply both sides by B and by 2. You would get B sine of 30 is equal to 2 sine of 45. Kind of the cool thing about this problem is that you can actually do this with exact radical form, because you know the sine of 30 degrees is 1/2, of course, and you know that the sine of 45 is rad 2 over 2. So you could actually go ahead and do this with exact radicals. You could say that this is 1/2 times B is equal to rad 2 over 2 times 2 is just rad 2. You'd multiply both sides by 2, and you get that B is 2 rad 2. So kind of cool. You actually don't even need to delve into decimals for that problem. All right. Now, again, since we have 2 angles to start with, we can find the third angle really fast. We're just doing our 180 minus, it looks like 75, because that's 30 plus 45. And you would get that angle C has to be 105. That's an easy one to find, right? So 180 minus the other ones. Now we're looking for side C, and I could just, again, use my angle A and side A and say that sine of 30 divided by 2 should equal the sine of 105 divided by C, and just solve for side C. All right. Molly says, if you plug into your calculator, is that okay, or do you need to use radicals? I would ask that if you can use radicals, to use radicals. But something like that would be the case like the minority of times, because if you notice here, sine of 40 is definitely an ugly decimal. That's not a nice unit circle value. So I'm going to ask that if you see all nice unit circle values, to keep it away from decimals. It's actually a lot easier to not use decimals, but if you see something like this might be a little tricky. Like the sine of 105 is just some like ugly thing. So we have to use decimals for that one. Okay, but that's a great question. So cross multiply, I would say C sine of 30 is equal to 2 sine of 105. And then, let's see, divide by sine of 30. So you get C equals 2 sine of 105 divided by sine of 30. And you'd get C is approximately, again, we refer to our calculator. We got 2 times sine of 105 divided by sine of 30. And we got 3.86. So around that to 3.9. And there you go. You've now found all of the sides and all of the angles of that triangle. Does that make sense to everybody? Awesome. So I think that the law of sines is a very straightforward thing if you are given 2 angles and a side. Notice that that's what we were given in this case. We were given 2 angles of the triangle and one of the sides that's across from those angles, right? So law of sines is very straightforward if we're given 2 angles and 1 side. Okay? That's when I think that the law of sines is straightforward. Okay, straightforward. Did I spell forward right? I hope so. Jeez. It's not 2 words. Straightforward. I think it's very direct as to what you need to do. Like these 2 angles is very clear or these 2 examples is very clear how we set things up. What's not as straightforward is if we're given 2 sides and 1 angle. That's what's not as straightforward. If we're given 2 sides and 1 angle. This is what's called, in the world of math, it's called the ambiguous case. okay, of the law of sines. Ambiguous meaning that sometimes you don't know whether it's one thing or another. The reason for that is because you can have potentially multiple different triangles that have the same side lengths but different angles associated with them. But things would still all kind of check out across the board. I'll tell you what I mean going into the next example. But know that if you're given two angles and one side, the law of sines is a very straightforward process, just like you saw up here. If you're given two sides and one angle, though, you could potentially end up with one solution. You could also end up with no solution, or you could end up with two solutions. And I will show you an example of each of those cases right now. One where it works out to one solution, one where it works out to no solution, and then one where it works out to two solutions. And I'll try to explain as best I can in this little abbreviated amount of time why the ambiguous case is the way it is. So let's go on to the back. Let's take a look at something that has one solution first. All right. So what if I told you that here's our triangle. We have our triangle ABC. This is not trying to draw this to scale, by the way. We'll say that's 68 degrees. We'll call this A, B, C. I'll say that this side is 5 and this side is 7. Right? The difficulty now is we don't really know what this angle is. We don't know if this is going to create an acute triangle or an obtuse triangle. So we can go ahead and try to figure that out. Your obvious starting point, again, should be to lean towards this because we want to find out what that C is. So just like before, I can say the sine of 68 divided by 7 is equal to the sine of C, which I don't know, divided by 5. We're going to need some sine inverse for this, right? Hopefully you're starting to notice that. I can cross multiply to get 5 sine of 68 degrees is equal to 7 sine of C. Divide both sides by 7. You'd get 5 sine of 68 degrees, all divided by 7 is equal to sine of C. And now I would just need to use the sine inverse on both sides to cancel out that sine. That's exactly what we do over here as well. And so we could just plug that big expression into the calculator. I could say we have the sine inverse of 5 sine of 68 degrees, all divided by 7. And we would get that our angle for angle C is about 41.47 degrees. We'll call it 41.5. Okay? Does everybody see how that works? Does that make sense? I'll look at the chat for a minute here. Okay, good. Yep, we're all good with that. But you may recall, just like before, when I had my area of a triangle problem and I solved for that missing angle, we had to consider the first quadrant solution and the second quadrant solution, because just like before, you know that the sign of any value is positive in those first two quadrants. So yes, this is a first quadrant solution that works out, but how about a second quadrant solution? Couldn't there also be another triangle in the second quadrant that has that same sign value? There certainly could be. So let's check. If this is our quadrant 1 answer, then our quadrant 2 answer would be 180 minus that 41.5, because that's how you find a reference angle. So what's 180 minus 41.5? Just doing it quickly on a calculator. Should be able to do that in my head. 138.5. So C could also equal approximately 138.5 degrees in quadrant 2. Or could it? That's the question. You could say, yes, theoretically in quadrant 2, your angle that would have the same sign value is 138.5. But if you notice, if I put this angle of 138.5 in for angle C, that plus my 68 degree angle well exceeds the 180 degrees that your triangle angles have to add up to. So in the context of a triangle, this doesn't make sense. And the reason it doesn't make sense is because of the fact that, again, it would cause your angles to exceed 180 degrees. Okay? So in that case, there is only one possibility. The one possibility is that this has to be 41.5 degrees. And now you can just go about your business to find what side B and angle B is. If you know this is 68 and that's 41.5, then you just have to add to 180. So you can do 180 minus 68 minus 41.5 to get what that last angle is. I got 70.5. And now you can apply the law of sines to find side B. So you can say that, we'll use A again as a reference. The sine of 68 over 7 equals the sine of 70.5 degrees divided by side B, which I don't know. Cross multiply and solve. B sine of 68 is exactly what we did before. Equals 7 sine of 70.5. Divide both sides by sine 68. You get B equals 7 sine 70.5 divided by sine 68. I'm going to go ahead and plug into a calculator. We got 7 sine of 70.5 divided by sine of 68. And you should get, it comes out to be about 7.1. So B is about 7.1. Okay? And so we've now solved for all of the sides and all the angles in that triangle. Does that make sense, hopefully? Logical? Hopefully everybody understands why we have to check for a second answer, because the sign in the first quadrant and second quadrant is positive. So how do you know if you're talking about quadrant 1 or quadrant 2? You don't know. So that's why you got to check. Here, quadrant 2 didn't make any sense because that would cause our angles to go way over the 180 degree mark. So hopefully that's logical. All right. Let me show you an example that has no solution, and then I'll show you an example that has 2 solutions. You might be like, well, how the heck could you possibly have no solution? I'll show you. All right. Consider an example like this. Here's again just our triangle ABC. I'm not trying to draw these to scale, just another ABC. All right. Another example. Suppose that this is 3, this is 4, and this is 70 degrees. Right? Again, your eyes should be drawn to things that are across from each other. So I see these are across from each other. These are across from each other. We don't know what angle B is, so let's try to find angle B. I can say that the sine of 70 degrees divided by 3 is equal to the sine of B, which I don't know, divided by 3. Oh, sorry, divided by 4. My fault. Divided by 4. Okay. Cross multiply, I would get 4 sine of 70 degrees equals 3 sine of B. Divide both sides by 3, you would get 4 sine of 70 over 3 equals sine of B. I would do the sine inverse on both sides because I need to get rid of that sine. Again, we're just going to pull out our calculator. We're going to do the sine inverse of 4 times the sine of, I typed a 7, I've said 4, I typed a 7. 4 times the sine of 70 divided by 3. And I hit enter, and oh, yikes. 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 Error. Error. Well, why is there an error? It might be not clear right now why there's an error, but let me show you what that calculation actually comes out to be. When you do 4 sine 70 divided by 3, right, you get a value of 1.25. What you would then be asking yourself by doing the sine inverse, you're saying the sine of what angle is equal to 1.25. Well, that's not possible because the largest sine value is 1 on the unit circle, right? That's the sine of 90 degrees, or pi over 2 is 1. The smallest sine value is negative 1. That's your 3 pi over 2, or 270 degrees. So if you get a value outside of that negative 1 to 1 range, how could you say the sine of anything is 1.25? You can't, because the biggest you go is 1. So not possible. I'm getting distracted because there's a bug flying around now. That's great. All right, so in any case, this problem has no solution because the sine of that is just not possible. In fact, it's not even really proper to be able to draw a diagram like this because you'd actually run out of measurement to actually be able to complete your triangle. Does that make sense to everybody? Okay, very good. So if you go ahead and plug into a calculator, you would say that there is no solution. And the reason, again, why there is no solution is because this value of 1.29 is greater than 1. And so it's impossible to find a sign where it exists. All right? Let me show you very quickly, because we're only got about 5 minutes to go, one problem that has 2 solutions. All right? Show you one problem that has 2 solutions. No. She's at work. Anyway, so she's not even here. In any case, otherwise she'd probably make a cameo. Let's go ahead and show a problem that has 2 solutions. All right? A 2-solution problem would be if I go ahead and draw a triangle. I'll show, and I'll explain again why there are 2 solutions. Draw a triangle. Okay. I have my A, B, C. Suppose that I told you that A is 22 degrees, side B is equal to 4, and side A is equal to 2. Okay? Suppose that I told you that. Well, again, to try to solve this triangle using the law of sines, I would try to go ahead and match the opposite sides and angles. I would say that the sine of 22 degrees over 2 should equal the sine of B, which I don't know, over 4. We can go ahead and try to solve. 4 sine 22 degrees should equal 2 sine B. Divide both sides by 2. You can get 4 sine of 22 over 2, which you could actually just reduce to 2 sine 22 if you wanted to, equals sine of B. Right? Now go ahead and do the sine inverse of both sides. Sine inverse of both sides. I'm actually going to plug it into my calculator as 2 sine 22 just because that's a lot faster to type. We got 2 sine of 22, and that should come out to be, let's see, 48.5. So we get that B is about 48.5 degrees. At least it could be if this triangle exists in the first quadrant. However, this triangle could also exist potentially in the second quadrant if I said our angle B could be 180 degrees minus 48.5 because there's another angle in the second quadrant that shares the same sine value. I would do 180 minus our 48.5. You would get that angle B could also be 31.5 degrees. And if you notice, that actually is a logical result. You could take 131.5 degrees, put it in for angle B, and you would notice that we are still under our total of 180 degrees. That would just represent that it's an obtuse triangle with these measurements instead of an acute triangle with these measurements. Alrighty? So, in the case where there's 2 possibilities, you actually do have to solve almost essentially 2 problems. You have to say, well, what if, because you don't, the reason it's called ambiguous is because you really don't know. What if this angle was 48.5? What would your triangle look like? And then you also have to say, well, what if it were, it's going to be actually a really like obtuse triangle, kind of like that. What if it were 131.5? What would it look like? Right? And so this almost splits off into 2 problems. Or not almost, it does. It does split off into 2 problems where you now just have to solve both triangles. Luckily, there's not really that much work. It might seem like kind of a bummer that you have to do that, but there's really not much extra work to do. All we really have to do is solve for angle C and side C. So even though you might be like, oh God, that's so much work, it's really not. We really just have to solve for this angle, then solve for this side, and solve for this angle, then solve for that side. Okay? I'm going to continue to do that now. I know that we're just about out of time, so if you have to go, you can, but I'm just going to finish solving these problems. I do want to mention there is work on Classroom due for next class, so make sure you get that done. Okay, I understand that we're going a little over. If you do have to leave, you can leave, but I'm just going to go ahead and finish solving these. So if that's the case, we'll start with this case first. If angle A is 22 and B is 48.5, then in order to find angle C, I would just subtract from my 180. I would get that C would be 109.5. Right? And then I can use my law of sines to go ahead and find side C. I can say the sine of 22 degrees over 2, that's angle A and side A, is equal to the sine of 109.5 over side C, which I don't know. To Molly's point, notice that this is definitely not an easy unit circle problem. This would definitely be decimals. So I would say C sine of 22 equals 2 sine of 109.5. Divide both sides by sine of 22, you'd get 2 sine of 109.5 over sine of 22. Divide both, you would just plug that into a calculator. I'd get 2 sine of 109.5 divided by sine of 22. We get 5.03. We'll just say that, we'll call that 5.0. So C is 5.0. All right. And we've now solved for that first particular case. We now also have to solve for the second case, in which this angle C would now be 180. Sorry, let me put it over here so you can see it a little better. 180 minus 22 minus 131.5. You would get that your angle C would be 26.5. Right? Now you can go ahead and solve for the side, where you can say the sine of 22 degrees divided by 2 is equal to the sine of 26.5 divided by C. It's the same exact solving process over here. Multiply both sides by C. Multiply both sides by 2. Divide by sine 22. And again, plugging into our calculator, we would get 2 times the sine of 26.5 divided by, divided by the sine of 22. And we would get that C is about 2.4. Right? So in this case, because both your quadrant 1 and your quadrant 2 angles check out and work, we would have to consider both possibilities. All right, and that just results in having to solve the triangle 2 times. Okay. Any other questions, comments, concerns about that? I appreciate you staying on a little extra today. If you do have any questions, please feel free to ask. Remember to do attendance on Classroom. Remember to get those problems done on Google Classroom in time for next class. And if you have any questions on any of the problems that were due today, feel free to come during office hours. Thank you, everyone, for your attention and focus today, and I hope you have a fantastic rest of your day and a great lunch. See ya. I'm going to go get that bug that was distracting me. I think it's a bee. Oh, I hate bees. All right, get that done.